Dear students, in this video, we will have a discussion on few problems based on Bragg's law or Bragg's equation. We all know that crystalline solids or crystals can act as diffraction gratings for X-rays. Based on this fact, that is, based on the fact that crystals can be used as diffraction grating for X-rays, let W. H. Bragg and his son W. L. Bragg derive an important equation known as Bragg's equation or Bragg's law. So today, let's see what is Bragg's equation and we will solve a few problems based on Bragg's equation. The Bragg's equation or Bragg's law is given by n lambda equals 2d sin theta, where lambda is the wavelength of the X-rays, d is the spacing of the crystal layers, theta is the incident angle, that is the angle between the incident ray and the scattered plane, and n is an integer where the value of n equals 1, 2, 3, etc., which is called the order of diffraction. If the value of n equals 1, it is called a first order diffraction. If n equals 2, it is a second order diffraction, and so on. Okay, so this is the basic equation based on the diffraction of X-rays by crystals given by W. H. Bragg and W. L. Bragg, known as the Bragg's equation or Bragg's law. N lambda equals 2d sin theta. In this video, we will see how to solve a few problems based on Bragg's equation. So let's see the first question. First order diffraction was observed for X-rays of wavelength 0.0712 nanometer at an angle of 8 degree 36 minutes for a single crystal of a certain solid. Calculate the distance apart of the consecutive planes. So it is given, it is a first order diffraction. So the value of n equals 1. We have given the wavelength of the X-rays. So lambda equals 0.0712 nanometers. The angle given, the diffraction angle theta, is equal to 8 degree 36 minutes. So you have to find out the spacing between the consecutive planes, that is the value of d. So let's see the Bragg's equation. We have n lambda equals 2d sin theta. So from this we can calculate d as d equals n lambda by 2 sin theta. Okay. So if we substitute these values, we will get the answer. So here we have theta equals 8 degree 36 minutes. So this 8 degree 36 minutes has to be converted into degrees. Okay, so that will be equal to 8 degree plus 36 by 60. So you have to divide the minutes part by 60. So that will be approximately equal to 8.6 degree. Okay, so we have to find out sine theta. So sine 8.6 degree. So this will be equal to, we have the value of n is equal to 1. So 1 into 0.0712 nanometers divided by 2 into sine 8.6 degree. So sine 8.6 degree is approximately equal to 0.14953. So let's substitute the value. So you'll have d is equal to 0.0712 nanometers divided by 2 into 0.14953. So this is equal to 0.0712 nanometer divided by 2 into 0.14953. 53. So that is equal to 0.29907. So the value of D will be equal to 0.23807 nanometers. So this is how we can calculate the spacing between the consecutive planes. If you want to express the same in angstrom, we know that 1 angstrom is equal to 10 to the power of minus 10 meters. So this is also equal to 2.3807 angstrom. So we have the Bragg's equation n lambda equals 2d sine theta. So from the equation you can calculate the spacing between the planes using the equation d equals n lambda by 2 sine theta. So substituting the values we will get the answer. Now we'll move on to another question. The first order Bragg's reflection from the 100 plane of a cubic crystal with D100 equals 4.5 angstrom occurs at a glancing angle of 19 degree. Calculate the wavelength of the X-rays used. Okay. So here you have to find out the wavelength lambda of the X-rays. So first let's write down the Bragg's equation. We have n lambda equals 2d sine theta. So what will be lambda? Lambda will be equal to 2d sine theta divided by n. Now let's write down the known parameters. We have n is equal to 1 because in the question it is given that it is a first order Bragg's reflection. So we have n equals 1. The spacing d equals 4.5 angstrom. The glancing angle is given, that is the incident angle theta is equal to 19 degree. We have to calculate the wavelength. So lambda will be equal to, if we substitute this, we have 2 into 4.5 angstrom into sine 19 degree divided by n. N is 1. So that is equal to 2 into 4.5 angstrom into sine 19 degree. So you have to evaluate sine 19 degree, and sine 19 degree is equal to 0.3256. So substitute here 0.3256. So this will be equal to 2.9304 angstrom. Question, you have to calculate the wavelength of the X-rays used, and using Bragg's equation n lambda equals 2d sine theta, we have lambda equals 2d sine theta by n. So substituting the values, you will get the wavelength of the X-rays used.